We are going to start with something called synthetic division. And what this allows us to do is exactly the same thing that I'm about to do. And it's a tedious process, as you know. This is asking me to find f of -4. So I'm going to do this in the traditional way, the way we've been doing it. All this is asking us to do is evaluate a function. Let the x's equal -4 and find out what the answer is. So f of -4, let me make this bigger. There, it's kind of increased, kind of grainy, but at least it's there. F of well, let's write f of x first. Let's write it nice and dark and big. X to the 4th minus x to the 3rd minus 12x squared plus 43x minus 28. And this is asking me to find f of -4. And so what that means is I put a -4 in for every x. And since it's negative, I have to use parentheses because I'm going to put this in my calculator. Now you can already see that this is taking a pretty good amount of time. And then I get the calculator. You either pull out your physical calculator, or if you have a digital calculator, you use that. Okay. And here I go. I am just going to put this in my calculator, and it really will be nice and big then. Okay, so parentheses, -4, parentheses closed, caret 4, come down or close parentheses, and then minus, not negative, minus x to the 3rd, which is going to be parentheses -4, parentheses closed, caret 3, come down. Minus 12, parentheses, -4, and then I'm just going to push the x squared button. Now let me make sure this is right so far. So -4 to the 4th, minus -4 to the 3rd, minus 12 times -4 squared. Okay, good. And here I am. So plus 43 times -4, parentheses, -4, parentheses closed, minus 28. Okay, so that's what I've got. Right here. And I'm going to hit enter. And I get -72. So I'll write that answer. Now, if you didn't get that answer, make sure you're using minuses here where you're subtracting and negatives in front of the 4. Notice here, let me see if I can make the calculator bigger. You have a minus button for subtraction. You have a negative button for negative numbers. Not all calculators are the same, but if you have a TI, graphing calculator, you will have the 2 buttons, one for subtraction and one for negative numbers. So negative 72 is the answer. And that took a good bit of time, because you want to make sure you have it right. But there is a quicker way, and we're going to use synthetic division. So one more time, I'm going to write f of x equals. Now I'm going to put the coefficients in front. Now negative 12 is a coefficient, 43 is a coefficient, negative 28, and it's debatable, but think of it as a coefficient. However, there are invisible ones in front of x to the fourth and x to the third. So I have to be very careful to write that, and you'll see why I want to. Okay, now I'm going to write the coefficients. 1, negative 1, negative 12, 43, and negative 28. Then I'm going to do something. This is a traditional mark. It's like the lower half of a box, or I call it a backwards L sometimes. And I'm going to take my negative 4 there and put it in here, negative 4. Then let me make completely clear that these are ones. And I'm going to skip this line and then draw a line. Okay, now, I don't want to go too fast because I want you to follow what I'm doing. I wrote down the coefficients, the numbers in front of the letters, that's what coefficients are, and the constant at the end with the signs in front of them. You have to be very careful to do that. And then I wrote negative 4 in a backwards L out in front of the coefficients. And now I'm going to go to this first number right there, and I'm going to bring it directly down and write it here. The rest is an automatic process. Watch. I take this number and I multiply it by this number. 1 times negative 4 is negative 4. Then I add negative 1 plus negative 4 is negative 5. Now, I take the negative 5. Am I going too fast? Somebody stop me and tell me if I'm going too fast, okay?
You're okay.
No, you're good.
Okay, well, anyway, I've got this negative 5, and I'm going to multiply it by negative 4, the number in the backwards L. Negative 5 times negative 4 is positive 20, and I write that under negative 12, the next number. And then I add these two numbers together. 20 plus negative 12 is positive 8. And then I'm going to keep up that action. Now I take the 8. I multiply it by negative 4, and I get negative 32. And then I add 43 plus negative 32 is really 43 minus 32. 3 minus 2 is 1, and 4 minus 3 is 1. That's 11. Then I take the positive 11 and I multiply it by negative 4. That's negative 44, and I write it down right here. And then I add those two numbers together. Negative 28 plus negative 44 is negative 72. And this is the number that I got here by plugging negative 4 into every x. This is another way, and a quicker way, quite honestly, because notice you don't do a lot of multiplying, not a lot of big multiplying, like, oh, what is negative 4 to the 4th power and all of that. Some people would much rather much rather evaluate polynomials this way, with synthetic division. This is one of the uses of synthetic division. So the way I like to do it, because I find it easiest, is to write down what f of x is and make sure I write all of the coefficients explicitly. Then right underneath, I write just the coefficients. Then I put the number I'm using for the evaluation, the number that I'm going to stick into the x's. I write in a backwards L over here, or the lower part of a box. And then I start doing this process. I bring the first number directly down, multiply it by the number in the backwards L, write that number there, and then add, multiply, write the number, add, multiply, write the number, until I get to the end. Whoever invented this was really brilliant. You'll see why in a minute. But right now, this is just another way to evaluate a polynomial. And I'm going to write that down. One of the uses. So much for that. Do you want to discuss this? We're not going to dwell on this particular use of synthetic division because we are going to be using synthetic division mostly for another purpose. Okay. Now, notice I even included the answers. I'm going to do this problem in a traditional way, and then I'm going to use synthetic division, and you'll see why synthetic division is so wonderful. Okay. Notice that what this problem says is we want to take x plus 2 and divide that into x to the third minus 2x squared minus 2. And then we want to get a quotient. And a remainder. Remember the remainder. The remainder is kind of left over down here. Okay, now, I am going to do this with numbers first, just to help jog your memory. We're going to go back to elementary school, or maybe middle school. I don't know where you learned this. What if a mean teacher like me comes up and says, let's divide 7 into 25? Okay, well, all right. 7 won't go evenly into 25, but it will go evenly into 21 3 times. 3 times 7 is 21. Then you subtract. 25 minus 21 is 4. Okay, and we're not dealing with decimals or anything. Now this number right here is the quotient. And this number is called the remainder. It's what's left over. When a number does not go evenly into another number, you get a remainder left over. Okay, now we're going to start this problem again, but we have to have a little talk. Here's our little talk. We're dealing with f of x equals x to the third, 1x to the third actually, minus 2x squared minus 2, but we're missing a term. There's an x to the 3, there's a degree 3, there's a degree 2, and there's a degree 0. Constants are degree 0, but there's no degree 1. You can't do division with polynomials if you don't have perfect order, perfect descending order. So we have to account for x to the 1. And I can't just go sticking in an x to the 1. That'll change the polynomial. But if I add 0 times x to the 1, well, 0 times x is 0. So I haven't really changed the monetary value, if you want to look at it that way, the numerical value. I've only changed the form. But now I can do this. If I'm using traditional polynomial division, which you may or may not have learned in high school, depending on how high you went in math, here it is, and I'm not going to ask you to do it, but I want you to see it. I'll have x to the third minus 2x squared plus 0x, that's a placeholder, minus 2, and I have to pull this all the way out. Okay, now the way I do this is this. I just look at this first term, x, and ask myself, how many times am I going to have to, or what am I going to have to multiply x by in order to get x to the third? And the answer is x squared. X squared times x is x to the third. Then I take this x squared and I multiply it by the plus 2. That will give me plus 2x squared. But I'm going to subtract x to the third plus that, 2x squared. Because up here, notice that I said 3 times 7 is 21, and then I subtracted. So that's what I'm going to do here. If I subtract x to the third plus 2x squared, then I'm going to distribute the minus sign, and that will give me negative x to the third minus 2x squared. So that's what I'll get here. So I'm going to erase my parentheses and the plus sign there. Oh, I could have left the minus part. And I'm going to write this down. And then I'm going to say x to the third minus x to the third is 0. Negative 2x squared minus 2x squared, or negative 2x squared plus negative 2x squared, is negative 4x squared. And then I bring down the next term, plus 0x. And this is why I need the placeholder. All right, now I start this process over again. What do I multiply x by in order to get negative 4x squared? That would have to be minus 4x. It would be negative 4x, but when I put it up here, it becomes a minus sign. So negative 4x times x is negative 4x squared. And I'm going to erase that 0 so it won't keep bothering me. Okay, now negative 4x times 2 is negative 8x. Oop, negative 8x. Now, I'm going to subtract this, just like I would with regular numerical division. And when I do, I'm going to be distributing the negative sign there and there, which will make this positive and this positive. Let me do it over here. You have a negative sign in front of negative 4x squared minus 8x. You distribute the negative sign, and that's going to make positive 4x squared and positive 8x. All right, so I'm going to write this down rather than this ugly kind of statement right there. Negative 4x squared plus 4x is 0. I'll just do that. 0x plus 8x is positive 8x. And then I bring down the next term, which is minus 2. This is the last time I'm going to divide. I ask myself, what do I multiply x by to get 8x? Well, that would be positive 8, which translates into a plus 8. 8 times x is 8x. 8 times plus 2 is plus 16. But I'm going to subtract 8x plus 16, which means I distribute the minus sign, which will give me negative 8x minus 16. So something my old algebra teacher taught me to do was this. This is positive 8x, and this is positive 16, but I'm going to draw the line and change the sign. Little rhyme there. Draw the line, change the sign, which is doing that. So 8x minus 8x is 0. And negative 2 minus 16 is negative 18. This is the remainder. This is the quotient. And that is long polynomial division. It takes time to learn it, and lots of mistakes before you finally get it down. Making sure that's negative 18 as I come down, down, down. Okay, now we're going to do the same thing with synthetic division. Okay. Again, what I have here, what this says, and I might need to make it bigger. X to the third minus 2x squared minus 2 divided by x plus 2. Now, I'm going to write that out. I'm going to write the f of x to the third minus 2x squared minus 2. Okay, and that's a 1. Let me make sure I copied it correctly. Minus 2x squared minus 2, yes. Okay, now 1, negative 2, 0, negative 2. Now when you do this, there is a little problem knowing what goes in the backwards L, because the number you're going to put in there is not 2. This is what you have to do to see what number it is you're going to put in the backwards L. Take your divisor. This is called the divisor. The number you would put out here in a long division problem. Take x plus 2 and set it equal to 0 and solve for x. So you have to you have to subtract 2, 2 minus 2 is 0, leaving me with an x, equals 0 minus 2, which is negative 2. Negative 2 is the number we put in the backwards L. So you always have to do that first. That's the one little complication. But look how much easier the whole rest of it is. I bring down the 1. 1 times negative 2 is negative 2. Negative 2 plus negative 2 is negative 4. Negative 4 times negative 2 is positive 8. 0 plus 8 is 8. 8 times negative 2 is negative 16. Negative 2 plus negative 16 is negative 18. And it's customary to make a dashed kind of forward L around the last number because the last number is always your remainder. But what's the quotient? Here's the quotient. The very last step is to find the quotient. Now, this is the coefficient of x to the third. When you bring it down here, this is automatically going to be 1 degree less or 1 power less. This will be 1x squared. And then your powers go downhill, your degrees go downhill automatically. If this is x squared, then this is x, and this is your constant term, which is positive, so I put a plus in front of it. Now this is the quotient. And this is the remainder. And if I did everything correctly, we will get the same exact answer. We have the same exact remainder. We have the same exact quotient. But this is tons easier and quicker than the other thing. Long polynomial division can be very tricky until you do it a whole lot. And then you still make stupid mistakes. I do. This is so much better. I love synthetic division. This is another use of synthetic division. Another use of synthetic division is a shortcut to long polynomial division. Truly wonderful. You almost never use long polynomial division except for a particular purpose, and we'll talk about that in the next topic. but the next topic is going to come after exam 2. Okay. What we in this class are going to use synthetic division for is finding the zeros of polynomials. Okay. If a number is a zero of a polynomial, if a number is a zero of a polynomial, it will have a remainder 0. Very, 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 very important, but you don't have to worry about memorizing it because we're going to do it over and over and over again today. Like starting now. We're going to see if two numbers are zeros or they are not zeros. One of the numbers is -3. And the other number is 2, and we're going to test them. Okay, so I've got f of x equals 2x to the third plus 3x squared minus 4x plus 15, and that x without a power does have a power, it's 1. So I have all my degrees here in order. This is a degree 3 term. This is a degree 2 term. This is a degree 1 term. And this is a degree 0 term. Okay, so we're right in order there. I'm going to write down 2, 3, -4, and 15. And a backwards L. And when they just give you the numbers, you don't have to do anything. You just take the number and put it right in here. -3. Then I skip a line, I draw a line, and I bring down the first number.
You use -3 because that's the x, right?
Well, we're seeing if it's a 0, You
Okay.
could also plug -3 in for the x's.
So you're going to do this for each number, right?
Correct.
Okay.
Correct. What I want doesn't mean I'm going to get what I want. What I want is to get a zero remainder. If I get a zero remainder, that means -3 is a zero of f of x.
Okay. Thank you.
Good question. Any other questions right now? Okay, let's see what the answer is. Take the 2, multiply it by -3, I get -6. 3 plus -6 is -3. Now -3 times -3 is +9. -4 plus +9 is +5. 5 times -3 is -15. Woohoo! And 15 plus -15 is 0. So -3 is a 0 of f of x. Now one more time. F of x equals 2x to the third plus 3x squared minus 4x plus 15. And our next number is +2. So 2, and then the coefficients 2, 3, -4, and 15. I skip a line and I draw a line. And then I bring down the first number. And then I take that first number and I multiply by 2. 2 times 2 is 4. 3 plus 4 is 7. 7 times 2 is 14. -4 plus 14 is +10. 10 times 2 is 20. And 15 plus 20 is 35. 35 is the remainder, not 0. So 2 is not a 0 of f of x. That's the test to see if a number is a 0 of a polynomial. Like I said, we're going to use that test over and over. It is. Let's see. Was I smart enough to do it? Yes! Okay. I was just imagining, no, I never drew the graph. But I did. Okay, let's read this. The graph of a polynomial function is given over there to the right. On the basis of the graph, answer these questions. A, find as many factors of the polynomial as possible. B, construct a polynomial function with the zeros shown in the graph. C, is it possible to find any other polynomial functions with the given zero? Excuse me, with the given zeros? And D, is it possible to find any other polynomial functions with the given zeros and the same graph? Okay. Well, we're going to answer them one at a time. Find as many factors of the polynomial as possible. Okay. I have to find the zeros first. -1, -2, -3. Ah, there's one. -3. -4, -5, -6. And +2. And +3, +4, +5. So I have 4 zeros. So let's call them Z1 or Z sub 1 is -6. Z sub 2 is -3. Z sub 3 is 2. And Z sub 4 is 5. And I also want to point out something I may or may not have said before to your class. I can't remember which class I say things to, probably your class. Is that when a line cuts through the x-axis, just cleanly cuts through it, the multiplicity of that 0 is 1. Okay, so all of these have multiplicity 1. Oh, 1, multiplicity 1, multiplicity 1. Which is good. Okay, now it says find as many factors as I can. Okay. F of x equals a times x minus z1 times x minus z2 times x minus z3 times x minus z4, because there are 4 zeros. Now, A, we don't know. So we're going to have to make some assumptions, and that assumption is that A is 1. I'll tell you right now, A is not 1. I'm fairly sure. But we're going to pretend because we have no way of knowing. So our 4 factors, because I can't find any others, are going to be x minus -6, x minus -3, and we're just supposed to list them. X minus 2, yeah, x minus 2, and x minus 5. So you have to start off with the minus sign being there. Then on the next pass through, you go ahead and fancy up the negative negative will give you a positive, and the negative negative will give you a positive. So the four factors are going to be x plus 6, x plus 3, x minus 2, and x minus 5. And that's the answer to part A. Now, part B. Part B. Construct a polynomial function with the zeros shown in the graph. Okay. Well, to do that, for B, what I do is this. I go ahead and assume that A is 1 because they have not told me what A is. F of x equals x plus 6 times x plus 3 times x minus 2 times x minus 5. So I am going to multiply these two together just because they're next to each other. And these two together simply because they are next to each other. No other reason. So let me make my little arrows. I'm going to take the x, multiply it by x, x multiplied by 3, plus 6 multiplied by x, plus 6 multiplied by 3, and do the same kind of thing over here. X times x, x times negative 5, negative 2 times x, negative 2 times negative 5. And that will give me x squared plus 3x plus 6x plus 18 times x squared minus 5x minus 2x plus 10. Does that look right to everybody? X squared plus 9x plus 18 times x squared minus 7x plus 10. And now this becomes a little harder. Okay, I'm going to use 3 colors here. I'm going to take x squared. Well, no, I'm not. Here's what I'm going to do. I'm going to take x squared, so let me come out here and give myself a little more room. X squared times this x squared, I guess I should. X squared times the second set of parentheses. And then 9x times the second set of parentheses. And then 18 times the second set of parentheses. And it's going to look like this. X squared here times these 3 terms, x squared minus 7x plus 10 Now plus 9x times x squared minus 7x plus 10 plus 18 times x squared minus 7x plus 10. And I just realized I'm sitting here in the dark. Excuse me. Now, I take x squared multiplied by x squared by minus 7x and by 10. And then, staying true to my colors, I'll take plus 9x and multiply it by x squared plus 7x plus 10. And then take 18, which is blue. Then take 18 and multiply it by x squared by minus 7x and by plus 10. And don't ask me why I didn't put arrows there. Okay, so here we go. X to the fourth minus 7x to the third plus 10x squared plus 9x to the third minus 9 times 7 is 63. Minus 63 x squared. 9x times plus 10 is plus 90x. Plus 18x squared. 18 times 7. That's 56. And 7 times 1 is 7 plus 5 is 12. That should be 126. Minus 126x. Plus 18 times 10 is going to be plus 180. Okay. Now, I have to get my like terms together. Okay, I want to make sure I did this right. 18x squared minus 126x plus 180. Okay. Now, x to the fourth it's the only x to the fourth, and the only constant is here at the end, plus 180. Oh, maybe it was a good thing I left the light off. It's flashing. Okay. All right, minus, all right, now, I don't know that that's a minus, because now I have to find my two x to the third terms. There's a minus 7x to the third and a plus 9x to the third, and I am not going to have any more third terms. Am I correct? I am. Okay, actually, I'm just going to write them down together. That will prevent any embarrassing mistakes. Minus 7x to the third plus 9x to the third Okay, plus 10x squared minus 63x squared plus 18x squared. Oh my goodness. All right. Plus 90x. Try this one. Minus 126x. All right, now we've got them all taken care of, I think. And then x to the fourth is taken care of, 180 is taken care of. Now all we have to do is combine like terms. X to the fourth. Now, minus 7x to the third plus 9x to the third is going to be plus 2x to the third. And now we've got 10 minus 63 is minus 53. Plus 18. 3 plus 8 is negative 53 plus 18. Come on, Barb. Negative 53 plus 18. Negative 35. Minus 35x squared. So these went together to do that, and these went together to do that. And now 90 minus 126 is going to be minus 36. Does that sound right? I think it is. Minus 36x. Yes. Plus 180. There's your answer. That's the answer we get when we assume that A is 1. A is the leading coefficient, 1. Okay? It's a lot of work. Okay, now C. We did A, find as many factors of the polynomial as possible. B, construct a polynomial function with the zeros shown in the graph. We did that. C, is it possible to find any other polynomial functions with those same given zeros? You bet. Yes. We can find an infinite number, an infinity of other polynomials. Just by using a different A number. Different. number, a different A. Because back up here, we're always assuming that A is 1. We don't know A is 1. The formula is f of x equals A times x plus 6. Well, x plus z1. Let's do it that way. X plus z1, the first 0, times x minus. Don't pay attention to me. It's time for a break, but wait. We're almost done. Minus z2 times x minus z3 times, need to move over, x times z4, x minus z4. There, that's the formula. By changing A, we change the formula. So there could be an infinite number of different A's, all having the same exact zeros. And D, is it possible to find any other polynomial functions with the given zeros and the same graph? No. If we found a different A, there would be different stretch or shrink. So it couldn't possibly look exactly the same way. If we knew exactly what A was, I would have put that in.